Everyone.
Yeah, sorry, I meant like,
again.
that's what I was thinking. So we're just going to do like intro.
From our Bitcoin donation that we got a while ago for the workshop. So if you guys want to come along and have a few drinks with us.
Crypto drinks.
Sorry?
Crypto drinks.
Yeah, I'm not sure whether they'll
Bitcoin
accept
powered
crypto.
drinks.
Do they accept crypto there now? They should do.
Yeah, but it's not
We go there quite often.
yeah.
We go there quite a lot. So I think it's about time. We may have to build a non-wrap solution for them in the meantime. But yeah, that's us. So we're very much a community-driven.
One Solidity and EVM on a programming level, not on a bytecode level, where that's the Termises one, which is advanced EVM. So next year, I'll increase the scope of this and cover more things, a bit more than this. So, and you're also free to join any future workshops, and you are all invited to the Slack channel, which is just for this workshop. It's not associated to any company. I'm not even going to mention which company I work for or what I do. That's just slightly different. So, but to give you a bit of context, I have been doing smart contracts since 2016, and the language has evolved quite a lot since then, and it still continues to be evolved. And I'm going to talk about a few things today. And the reason I can talk about this is because I've already have contracts on mainnet running, which are already dealing with value with a few projects that I've worked on, and this is something going to start from very generic. So we are going to talk about patterns and how to do things from an implementation point of view, but abstract. So we're not going to go dive into the actual code for the next 1.5 hours probably. And the second half of the workshop is entirely yours. I am only going to be there. I'm going to show you things, but you are going to be the ones who are going to present. You are going to be the ones who are going to learn from each other, and I'm just going to observe. So I'll show you the documentation and other things in a second. But you have the Slack channel. Everyone is on the Slack channel, right? Okay. Can I see how much experience do people have with Solidity? Have you ever written Solidity at all?
Just some.
Okay, cool. So for anyone who's not, that's perfectly fine for the first half. And then when we actually start the deep dive, it goes in incremental. So we're going to start with very basic, and you're going to look at me and say, are you seriously asking me to do this? But it goes advanced very quick. So there is incremental tasks that we'll go through, but I'm going to go through just different patterns of upgrades from the start. So, any questions before I start? Okay, cool. Okay, so what do we want to do for the workshop? And the first thing is that you should know all the different methodologies which exist. It basically means you're going to go out there and people are going to talk to you about, well, they're basically going to throw you words, just fancy words out there. There's going to be transparent proxy, blah, 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 blah. You should not care about what things are called, but how they work. So there is patterns that you will like, which you can use right now, and there's patterns that you should know about because you may need them in the future. They all are complementary. There's never one pattern that always lives and other one never being used. And any pattern that I do talk about, they all are in production in one project or another. And if you find it, you will see. And they've all done like researches into saying what problems they faced. So you already have all the learnings of every project that use any of the patterns. So know the advantages, know the disadvantages, and know the actual scalability of that pattern. Upgrades can be done, but they can only be done at a max of n times. And that max is not determined by a theoretical limit, by its practicality. It will just become unreasonable to keep upgrading the same thing. So that's where you have to migrate or do something else. And that's something you would see. And this is actually going on. How many people know about Aragon? Okay, so Aragon is a company that's been building governance on top of Ethereum for almost 2 years. And there was a hard fork called Istanbul going on, I think in the next couple of days, or if not already happened, which is going to break all of their contracts. It's about 5,000 contracts. So they decided to build their own chain. And they're going to build their own chain in the next quarter because they cannot rely on Ethereum to keep breaking their stuff and they keep fixing it. Which is essentially going back to, you can argue, oh, did they write contracts with certain assumptions? Well, yes. And you will always have some assumptions and they will get invalidated. So yes, they can do upgrades, yes, they can fix it temporarily, but they have no choice, but they can't do that forever. That's not a system that's scalable. So those things are always fun to know about. And then there's also hacks around different patterns. So you must know the details down to the very bottom of everything you use. There are tools out there which makes all of this easy for you. And the reason I dislike them is the developers don't know what they're doing. So while it makes your life easier now, when you actually come to do the upgrade 6 months later, you don't know. The tool has evolved, the chain has evolved, and the language has evolved, and now you have to trace back all the links and connect them together and see what actually happened. On the other hand, if you do it yourself, and I'll show you why it doesn't make sense to use those tools, because they do give you like 5 lines of code for free. So it's where like, okay, does that dependency make sense? To me it doesn't, but if it does, feel free to use them. I'm not gonna say anything. But that's the general aim, and we're gonna go through each one of them, and we're gonna criticize every pattern. So we'll see. Cool. But most importantly, have fun. So this is a learning opportunity. Make as many mistakes as you want. Keep breaking stuff. You know, there's no value involved right now, but in your next projects there will be. So if you break stuff now and if you find stuff now, that would be really helpful for you in the future. And that's the best way to learn. So there's always things that are changing, and if you keep breaking stuff, you would run out of things that you've already broken. So that would be a good way to learn. Cool. I'm actually just gonna ignore that. But what do people think? Yes? No? How many people think yes?
Maybe an EVM code.
What do you mean?
I think the language has to support true upgradability,
Okay.
and I don't think Solidity does. But I
Yeah.
might be wrong. You put your hand up and you know a lot more than me.
No, I was just
Yeah.
saying like how quick put your hand up. I was actually no, it's so the thing is that they keep changing things. So in a traditional world where things happen, you can actually know that there is a breaking change and not upgrade for that. In the world of Ethereum, that's not the case. Every hard fork contains something critical which will break your contracts if they're on mainnet. Because when you wrote them, you had an understanding that had to be re-verified at every hard fork. So the fork that's going on right now is Istanbul. The previous one was called Constantinople. And that introduced a feature called Create To. Now, generally when you deploy contracts, they get an address, right? And that address can never be reused again. It's based on announce, it's based on who's creating it, and it's based on the bytecode of the contract. And because there's a nonce involved, which never gets set to 0 again, and the nonce is essentially number of transactions that you send, and once you've sent a transaction, it never goes back, therefore it was immutable. Now, Create 2 does something called counterfactual deployments. What does that mean? Well, that means I can start a payment channel with you directly without even consulting the blockchain. So I can reserve addresses or I can park addresses. And how do we do that? Well, you need only, now take out the nouns, which was the factor which was actually making it unique and saying you can't reuse them. You replace it with a random hash or just anything random, just a salt. So now you need only 2 things. One is the bytecode, which, well, the init code, which will create the bytecode once it's run, and then some salt. Given these 2 things and your address from which you're going to create it, you will get an address where your contract will reside. So now that address is yours, given no one has the exact same information and no one has your private key, you can guarantee that at any point in time in future, I can reuse that address. So that was the feature. What was the problem? Well, they didn't actually think about self-destruct. So in Ethereum, you can destroy contracts. They are gone forever. They never come back. They're just erased from history. Well, erased from memory, but it's always in history. With counterfactual deployments coupled with self-destruct, you can keep doing that again and again. So you can reserve an address, do something there, delete it, and move on. And keep doing that for eternity. What does that actually mean? That means you cannot actually trust an address to say that the contents or the code that's stored at that address will remain the same forever.
It's mutable code now.
Sorry?
It's no longer immutable.
Yes, but arguably it never was. So there's no immutable code because the idea would be, even if you do normal things, if there is a hard fork within the blockchain consensus layer, it can still go different ways and do something else. But that's way harder. So, and that's what happened with the DAO hack, where they actually gave money back. So now then there is a way to make contracts truly upgradable, but what do you think about having a contract which is fully upgradable in any way?
If it's version, I'm alright with it.
It's not version. It can't really be version because anyone, like there's a single person who can just decide to change everything, and there's nothing.
Yeah. Couldn't run.
So that's a pattern that emerged as a consequence of something they didn't think about, and that's not really used. And the reason is, if like any of you are auditing a contract which has a self-destruct and it also has, it's been created with create 2, now there's no point of using a smart contract anymore because you're saying just trust me. And if I have to trust you, then why do I have to go through this massive painful thing of blockchain, and why can't I just go to database and just have the normal things and
Have a nice Java program.
yeah, just doing that. Just go with normal things. So we're not going to actually go through that way of doing things simply because it's not something that people use in production or not the one I've seen.
So in Istanbul or further, are they trying to correct that?
Now, once something is done forever. It's going
No,
to
in the
remain.
next hard fork, are they planning to correct that?
No, never.
Okay.
Once something is done, it's done. There's never any corrections. It just breaks things. It does Istanbul breaks a lot of contracts and it changes everything. So I don't know. In the last 2 weeks before the workshop that you attended, where we said how to send Ether, and I don't know. Are we still suggesting you to do transfer because that's now broken? So with Istanbul, a lot of things that we would have said are safe ways to do things are now broken. Just wouldn't work in normal ways. So, and that's just It's bad development practice, it's bad, but that's what it is. So now all the security assumptions that you had before have to be reconsidered with the new hard fork because they've changed the rules of the game. And every time you change the rules, everything is now questionable.
Can I ask a couple of quick questions on
Sure.
Istanbul? One is, I presume they're not moving to proof of stake with
No.
Istanbul, they're not there yet.
No.
And the, what's more relevant to this? Sorry, I forgot.
It's okay, you can come back to it. Cool, so I'm gonna move ahead with that and go to actual things. And so before we start, it's always,
Sorry, just
Yeah.
because I've remembered, on these hard forks, do they ever change the EVM specification target?
so they change opcodes and how they work,
So
which
they do.
defines the EVM entirely.
Yeah,
Yes, so that's what the EIPs, so there's an EIP 1884, which changes, I think, S load and S store. The price
so
for that,
because I know that's formally specified, so it might be kind
they,
of correct, but they still change it.
yeah.
Yeah,
It-
well-
So formally specifying anything does not prove anything.
No, absolutely, yeah.
Yeah,
So it's almost a new system, right, when they change
Yeah.
it? Yeah, okay, thanks.
yeah, so that's, and again, one thing, so the advanced patterns that we use in blockchain, in upgradability, they cannot be formally verified. It's impossible to formally verify a pattern that uses dynamic things. You can formally verify situations, but you cannot formally verify things that are dynamic. There's no guarantees anyone can give you about some of the patterns I'll go through. Some you can, others you can't. Okay, so what do we care about upgradability? So a lot of you would have started with blockchain because it's immutable and we're like, oh, we can have this piece of code running and anyone can execute it and it's never gonna change and that's what trust is. That's what trust is, and landlords can take rents from there and so many different use cases and so on. But here comes the problem. Developers like me make mistakes. And we can code up something that works really well for a year, and then it breaks, or then there is a bug. Then there's only two choices. Either you're willing to lose the money, or you're willing to say, I want to trust the person who's operating something, or I want to partial trust someone. But there's also another case where it's not the developer, but the actual foundation blockchain changes. So the example I've given with Aragon, it's not their fault. They've coded their contracts properly, it worked properly. This change was not there, even proposed when they started this. So it's not their fault. Now, if they hadn't done an upgradable way of doing things, they would have to redeploy 5,000 contracts. And deploying 5,000 contracts will first cost you a lot. Second, it won't be that it won't be that fast because 13-second block times. So you have to be in the middle somewhere. If you're doing something which only takes like 10 pounds, don't care, make it permissionless. So if it's only between two parties, make it permissionless. So if we're doing, for example, a state channel between you and me, and we know, oh, we're gonna play like 10 pounds or 50 pounds, fine, we'll make it permissionless, no problem, because we don't need upgradability there, essentially. We just
What do you mean by permissionless?
So when we add upgradability, we add permission. Because someone now has to have the authority to actually go and upgrade the system when they want.
So anyone so you may, if you're only paying with really low amounts, you let anyone in the universe, in the world, could upgrade?
Not really. It's generally always do the person who's deploying it. So before you enter the contract, you already know that the company can always upgrade this system without your consent. Now, there are governance proposals which basically say people have to vote and so on, and you go into that voting thing. But I'm not going to go into governance. So, because of all of this, we need upgradability. Does that make sense? But as I said, if the value is so low that you don't care about losing it, it's perfectly fine not to have upgradability. If the value is like £5 or something, where you basically say, I would rather say, because there's the consequence is you lose permissionless if you do upgradability. If you don't do it, then you have a permissionless system that anyone can do anything. And everyone is equal. There's no privileges. As soon as you add upgradability, you add some sort of permissions on top of it, where you say, that guy can come and do this. And now that guy can be another smart contract, which we can talk about.
Sorry, I have a question which maybe is a little bit what you said, but does gas price actually depend on the market price of diesel?
Not really, but it depends on the congestion. So,
Does it mean that like if it costs £10,
so what I'm saying is like sometimes you write smart contracts only to do simple things, where
like that was more illustrative.
no, no, that's different. But what I mean is, for example, we can have a contract which is saying, generally people limit, so for example, Raiden is a state channel network where they limit the amount that you can put into a contract. So basically they say you can only put like 0.5 ether into a contract, which today is probably £50. And the reason they do that is to say, well, we're still developing, there may be bugs, we don't want to add permissions on it. So instead, if you lose £50, and everyone's happy with that. So you're like, the maximum loss, you cap the maximum loss at some amount.
Yeah, okay, yeah. My question was more like the maximum loss, is it, because everything is defined in ether, right?
Yes,
Like ether has a market price.
yes.
But is there a relationship between the two? When you define the contract?
No, you don't care. Generally, you don't care. So you don't care about the gas price essentially at all when you're writing contracts. You only care about how much gas is consumed. And the reason is, if you have a for loop in your contract, then there will be more gas that will be consumed, the number of iterations. Same thing with various different things. But there is like weird cases which it will be too complicated to go right now.
So we should think in terms of gas volume.
Exactly.
When you said Raiden's a state channel network, state channel, could I think Lightning? I know that's Bitcoin.
Yeah, it's
but
essentially. Raiden is like a Lightning for Ethereum.
Yeah.
But they've been in development for ages, and I don't know when they will go live.
Which is, it's on, is it off-chain, on-chain?
Yeah.
Off-chain.
That's basically Patrick's.
Patrick's project. Oh, cool.
Yeah.
Yeah.
So just a disclosure, I worked in Pisa for a few months, which is therefore, like you'll see me mention state channels more than a publisher. So, but yeah, that's one thing.
And it's a way of getting lots of people to agree to make a transaction happen where a lot of processing is on-chain, but the secure bit and the coin transfers are still on the blockchain.
Yes. It's a way of micropayments essentially.
Cool.
But don't worry about that. Let's not go into that too much.
Sorry.
But we can go through it in lunch if you want.
That was fun.
Cool. So last slide before we dive in. Even though they are all used in production today, even though they are all being used for a long time, about 3 years now, but the problem is that given always the EVM layer is constantly changing, there is no guarantee that the code you will write today will work tomorrow or even a year's time or like any longer time. So you have to always know the code that you've written still works, what are the changes and what is going on at each line, so you understand everything that's going on. Cool. So, what are the two ways of doing stuff? Well, one is you don't care. You start writing a contract, you just write whatever the thing you want to do, get on with it. If there is a problem, you write a new one. And we're gonna go through what's the problem with those. What's the other ways? Well, the other ways is that you start pre-designing your contract in a way which is already allows upgrades. So you start breaking down all the problems and you go into them. And there's two ways to do that. And we're going to go through that. So, I talked about this in a bit, which is the current state is you can have trusted means to upgrade. So as I said, as soon as you add upgradability, you need someone to do the upgrade. You can't let the whole world do it because then that would be chaos. And to control it, you have two ways. One is that you can say a single organization, a single other contracts, a multi-signature contract, something can do the upgrade. Or you can say, you can make it fully trustless and say, everyone can only do upgrade for themselves. So I have to manually do upgrades. And this is one of the examples of, if you know DAI, the stable coin. They recently moved to a multi-collateral DAI system where, everyone has to manually migrate and move to the new system. So that's fully trustless. They cannot steal users' funds. The problem is you can, if you're building a system that relies on this, it's really tricky because you can never ensure, because one thing is that, well, you will congest the whole of Ethereum's network as soon as you go there. And with this is not good either because the company can take away your money overnight and you can't do anything about it. So one of the things that you may think about is, can there be a way where you can do best case upgrade on this end? So, well, the company did everything, they already have a good reputation, it's a minor upgrade, I don't want to pay any fees for them to upgrade, because if you're on this end, you have to constantly pay fees every time you do upgrade, because you have to send a transaction. And that transaction costs you money.
This question, so in the trustless side, what you're saying is that every person who wants to upgrade has to upgrade it themselves.
Exactly, so they have to send a transaction.
So they have so in that particular thing you are talking about end smart contracts.
Yes, exactly. So everyone has their own contract which they have to upgrade.
Right.
And we're going to talk about that at the end as well.
So if it's trusted, say it's multi-sig,
Yeah.
multi-parties, presumably it's still the same cost, but you share that cost? Or...
No,
No,
because
I'm
that
confused.
trusted means only 2 or 3 people or one person, let's say, but you're trusting them. So basically you're saying, I'm the company and I can have like 3 board of directors and you are all the users. I can do upgrade at any point in time and there is no consent that I don't need your consent, I can just do it. But there's 3 people instead of 5 million, for example.
But isn't that like a business model now? So for
Yes.
example, there would be certain use cases where you don't want to have end smart contracts or end versions of it.
Exactly.
Whereas there would be other use cases like Maker and DAO, where you're actually creating a CDP, every person creates their own CDP.
Yeah. So as I said, I'm not favoring one for the other, I'm just saying that there exists.
Right.
And we're just thinking about possibilities. So there's many different possibilities which exist. We just have to know what are the costs of going with each one.
Okay.
So with this, you can never guarantee that every single person will always move to the next system.
Kind of like a Java upgrade.
Yeah. So there will always be some people running
Java
old things. So yeah, we're gonna get to that at the end. But there's only one philosophy, which is your design must be simple. Whatever you do, if you can't understand it yourself, then no one else is going to understand it, which basically means there are hackers out there which are constantly looking for contracts which have value, and there are constantly ones which are being hacked. So be careful. And always design things simply. And if you want an example of this, you can look at ENS, Ethereum Name Service. That's one of the ones which have had millions of Ether stored. And if you look at the contract, it's like 20 lines or 15 lines. It's the bare minimum that you need to make something work. And if you have it that simply, then basically there isn't that many options of someone hacking it, because it's like, well, you can go through each line a million times.
Unless the platform changes.
Well, unless the platform changes, but there are developers who build the thing themselves, so they know what they're doing.
Ali, sorry.
Yeah.
On a more basic level, I don't quite understand what trusted means.
Okay, we'll go through that.
It'll become clearer.
Yeah.
Great.
So we're gonna go through that. And when you implement it, it will become more clear, because you're gonna be the trusted party.
Right.
Okay, so first thing first, deploy a new contract. So you start writing a contract, you finish it, and now you realize, oh shit, I missed a function. But it's already deployed to mainnet, and there was no way to upgrade. So what do? You deploy a new contract. And let's say that there was like 3 months difference between this one, and this contract was being used. We don't actually care about the contents or what we actually changed, but what are the main disadvantages of doing this? What are we losing out?
Have to pay to deploy the new contract.
You have to pay to deploy the new contract, yeah?
You can't guarantee that the old contract is still not gonna be used.
Yeah, you can't guarantee that like people are not using the old one, yeah?
Isn't there congestion as well, like having millions of contracts on Ether that are not used?
Yeah, it's an indirect consequence, but yeah.
And if that contract is holding money, then that money is lost.
Yeah, I mean technically unless it stopped working, but yeah. What are the direct things that users, so let's say if you were a user, from a user's perspective, what do I now need to do? If I was using this contract A,
I need to tell everybody there's a new
so
contract.
the company needs to tell everyone that.
They screwed up.
So what has changed? I mean, not necessarily screwed up, but what has changed?
The address.
Exactly. So one thing is the address. So that's one problem that we have to face. The user cannot talk to the same one now. They have to talk to a new one. But there's one thing else. This contract has been in use for 3 months. This one just deployed. So what does this one has that this one doesn't?
History.
Exactly, history, data. It just doesn't know anything. So if this was an ERC20 token, this one now knows nothing. So there has to be migration. This is something I call migration, but I think it's by the definition, where you have to take contents of one contract and transfer it to the other manually, which basically means you're going to make mistakes. You can make mistakes. And you can do various different things. The contracts may not be compatible at all, but it does give you the flexibility that you can change this entirely. You can do anything you want and no one's stopping you. So you can basically, you don't have to care about any interfaces, you don't have to care about anything, just rewrite this entirely. And that's perfectly fine. But it comes at the cost of doing a manual migration from the other contract to the new one. So 2 things that are changed which we care about. Address. So the user now has to know there's a new contract. And imagine if we're doing like normal upgrades, which are like in normal software every 2 weeks, every week, something like that. They have to constantly keep knowing the new address, which is a nightmare. But they also, every time you do an upgrade, you have to ensure that the migration did not screw someone up. You did not censor someone, because this is a manual process and only like one person is doing it, which means someone can censor things and so on. But we have these 2 problems we're going to work with: an address and data. Does that make sense? All good? Cool. Okay, so let's look at this. So what does this solve? Keeping the logic and data separately. Does that help? So what are we doing? So we're saying we had a problem with the data where every time we made a new contract, we were losing out on the data that was in the previous contract. Now, what if we just abstract away and say, well, we're just going to store data in one contract, and any logic which modifies that data by any means is going to remain outside. So we're going to have contracts divided by logic and data. And now you can keep doing upgrades as long as they just modify the logic. So you can modify, for example, if one function was adding 1, it can add 2 now, and this is a raw database. So it doesn't care what you're doing. It just exposes some functions and it lets you do whatever you want.
So typically what is there in that?
Right? Yeah,
So what do you actually normally keep over there? Data structures?
yes. I'm going to show you that in a second. That's the next one. Any questions about this?
So is
Yeah.
it something based on API calls or something like that?
More or less, yeah. So,
So you're still keeping the API same, but the implementation might be different.
yeah, so you can think of this as the database that you're changing. So that's your, you can define your own models or whatever. And this is your API, which is changing the logic.
So would the interaction be almost like CRUD operations?
More or less, yeah.
Create, read, update, delete,
Okay.
that's all you do in the contract
Storage contract. Yeah, exactly.
And also store the actual data.
Exactly.
So does that mean from the beginning you want to contract?
Yes, exactly. So when you start, you always start with like 2 contracts, and you can keep adding more logic contracts, which make the logical ones. So remember, this contract is completely stateless. It holds no state whatsoever. It can be thrown away at any moment, and you wouldn't lose anything. The only contract we care about is this one.
So what happens if you want to change the data structure?
That's an interesting question, and yes, you can do that.
So
Now,
does that mean that one of the contracts is continually calling that contract?
exactly. So that increases cost, which is very important. Yes, so it's basically just saying, you call me, I'll call someone else and get the data. Essentially how we do it in APIs, where it gets the data from the database, then does something, updates it, goes back. So, the question is, okay, one thing before I go to that, which is, remember that this is like a database. So it means that not everyone can change this, or not everyone can actually interact with this directly. Which basically means this needs to be now held in a way which is it only allows one contract or one public key to do things with it. And how do you do that? How many people have heard of the ownable pattern? So ownable is basically saying every time I get a call from someone, I'm going to look at who called me. And when this contract gets constructed or deployed at the first step, it stores who originally created it. So it stores an owner who was the creator of this contract. And it says, I will only allow whoever created me to change any contents that are within me. Does that make sense? Okay. So, yeah.
So, but if I then deploy a different contract,
Yeah, I'm gonna get to that.
oh, sorry.
So, that's fine, but then this contract also exposes one more function, which says, whoever my current owner is can change the next one, so it can assign someone else. So it can basically say, contract A can call it and say, I'm retiring, and you're now in control of this person. So essentially how CEO changes or something like that, where you just change the pointer, which basically means as soon as this contract comes in, A dismantles itself, and now contract version 2 is in control, and this link is broken. So this link doesn't exist anymore.
I thought users could still use contract A.
In this case, no, because we
yeah.
don't want them to.
Got you.
So this one you can actually
So
tell,
it's
like make
forced upgrade.
exactly. Because now, but remember that someone owns contract A2, and now that could be a contract, but for simplicity, let's just say it's one person. It's one public-private key pair, which can just say upgrade to this.
So what happens if I go to contract A, because I still might have the old address?
You can, all transactions will fail, because it can no longer access its database. So exactly the same thing that you call an API which can't connect to your database, what will happen? Things will fail.
So does it tell you that, okay, you need to go to this new address, or how do you get to the new address?
That depends on whether you code that up or not, but no. Generally, you would basically be like, oh, what happened to the company? You'll go to the company's page, look up something, and it will tell you, okay, you're using a wrong address, or an old address. So, something like that. But it's up to you on how you want to define that. But the general principle is the same. So, do we agree that we've solved the data problem?
No, because what happens if you want to change the data structure?
Okay, I'm going to first mention the specific data structures that you can use. And now we're going to look into how do you actually define this in a way where you don't have to do that.
Okay.
Can I actually define this contract or write it in a way where there's every data structure that's possible exists? That would be interesting, right? Okay. And again, you will also be able to reduce costs. We're going to get to that. So an optimized version of this. Okay, mappings. People know what mappings are? Hash maps? Okay, so we're going to go to that. Mappings are this infinite key value pairs, which can have things that exist within them, and they can store infinite things essentially as long as the key is unique. So as long as you can give me unique keys, I can guarantee you there will always be slots. Now, there is something called byte 32, which is just a data type in Solidity, and it's very optimal. It's an optimal storage, and the reason is EVM stores everything in 32 bytes. It has like every slot is of 32 bytes. If you store something that's of 8 bytes, it will still take up the 32 bytes. It will just have to pad the rest. But it cannot give you anything less than 32 bytes, which therefore means every time you want something, regardless of whether you're storing a uint4, uint whatever, you will always get the full slot. If you don't use it, that's perfectly fine, but you will be charged for a full slot. Now, what we can do is we can generically say that the keys are always going to be bytes 32. So regardless of what we want to store, we can keep the keys as bytes 32, and then we can have different values. So uint 256, all the uints, all the strings, all the booleans, all the other things that you want, you can have them. Now, you see, the reason I have dots here is because you can keep going on every single data type that will ever be used. And mappings don't cost you anything at the start because there's nothing in there. Mappings only cost you things when you put something in there. And mappings are not iteratable. You don't know what's inside a mapping. You can only when you give the key that it can look it up and tell you that something exists, because everything exists in a mapping. It just has default values, and that's how we find out whether something that we've put in or no.
So there's no enumeration on any mapping.
Exactly. You can only enumerate on arrays, but you can't enumerate on this. And they are stored as in like RLP encoded. So if you define this storage contract as just several mappings which define every single data type that you will ever use, and this is an optimization. So what's the function that takes any string and gives you a byte 32? Yeah, takes anything, it takes an array of strings. Yeah, so kcat 256 or any hashing function essentially, well, in this specific case, kcat 256 will give you a byte 32. So what does that mean? Well, it means that we're optimizing how things are stored. So we're basically saying if the key is always byte 32, and we can hash any string, so you can say something like score, and you can hash the score to get a unique thing, and then you can store it in this unit map. The next time you need to store another variable, you just hash that variable, so apple, whatever, and you store it in this mapping again. And you can keep doing that forever as long as you have more words in the dictionary, or not necessarily words, anything.
Are you trying to say that don't fully compile your contract, storage contract, just tokenize it and start to store it, that's it?
Yes, so storage contract is just for storage.
So it's just basically just like you have got a program, you have got a program, the first thing you do is compile, try to do something, compile it basically just first thing is tokenize everything. And then you're saying that, okay, we tokenize everything, so you just store it there.
Okay, yeah, so
You don't even need to worry about how to actually link it together later, because this is separate logic.
that's where things are here. So, okay, yeah, I see what you mean. So what you're saying is the references of what these bytes 32 actually mean will not reside in contract storage, they will reside here. Or even if you want to take it one level back, they can live somewhere else in another script if you wanted to. But generally, you always store the references here, and you store the actual things here. And this is a very optimized version of this. And as I said at the start, you don't have to use every pattern that I'm mentioning, but you have to know. So this pattern is used by a company called, I think, Rocket Pool, which implemented this, went on with it. I think the contract is still going on with it. And they wrote an article about what's good and bad about this. What are your thoughts before I go into those?
Just a question.
Yeah.
So when we map, shouldn't it be the other way around? Shouldn't we say uint56 maps to bytes 32 because the hash function outputs a fixed length, so we want the output to be the fixed length. Not
The output will be the fixed length, but that will be the key, not the value. So you're hashing the key. So remember when you start to define variables, for example, let's say if you were defining contract storage normally, right? You would basically have a bunch of variables, arrays, and stuff like that, right? Those variables will have names. All we're doing is we're optimizing by saying take that variable name and hash it to get bytes 32.
Okay.
So
So
there's-
we hash it and then we okay.
Exactly. Okay. So what's the main disadvantages that you can think of for this, or advantages?
How do you express relationships between data?
You don't. You do it. You have to know them here. You have to know them in the logic contract.
The stuff just sounds to me like, remember this one time ago, I was writing this kind of enterprise software. Every single log message, you need to have something like 8 number, like PHY0001, and then H1 error number 3
Yeah.
or something. And then basically they all have to be stored in somewhere. And then basically every time we're going to say, there's an error, and basically just call this code. And this is an error. So you have it starts to sound like every error message, every string or every constant need to be codified, put into this contract storage area that can be probably translated to another language later.
So
And then so basically all the rest is basically just keep in different versions. I mean, you can say different version of the
Yeah.
software is kind of like, right, okay, yeah, you're going to generate pretty much most of the same. You're going to add one or two, and you can ship it separately.
yeah, so again, we're looking at a pattern,
Okay.
and specifically looking at advantages and disadvantages. And this is so in the blockchain world, things are not that simple. It's not that developed for you to say, oh, you know what, I'm just gonna go and do SQL or stuff like that. That doesn't exist. So we have to do what we can.
Well, one basic question here. So we talked about, you said, maybe I'm skipping. So you said that the key is basically hashed as a bytes 32 value.
Yeah.
So and you're expressing so it's a key value pair.
Yeah.
Right?
Yeah.
So essentially, what you're saying is that originally what would have said as int a is equal to 1, you're going to say the a is bytes 32 hash.
Yeah.
And then you're going to send the 1 along with it.
Exactly. So it will expose functions, which will allow you to do that.
Values are typed.
Yes.
And what was the company that's documented this?
I think it's Rocket Pool. They may have changed now, but as far as I remember.
So by looking at the value you can tell whether I want to put it in the uint mapping or
Exactly.
mapping.
Yeah. But they will all expose different functions later on. So they will be like set uint, set
Right.
set string, set boolean, so on, and then you will pass along the relevant ones, and they will care about that. And you're going to implement this today, so you'll get an idea of this. Okay. So
How expensive is it to store values and retrieve them?
So the problem is that you will be making dynamic calls. So if you actually did it, for example, with strings, passing strings are dynamic arrays by default. That's how Solidity stores them. Dynamic arrays are very, very expensive because no one knows how much things are. And given that this contract will be reading quite a lot, it wouldn't be feasible for you to store them as normal values, like as normal things, because then it will be unreasonably expensive. So one of the disadvantages of this, as you can already think, is this works very well if you have very limited number of variables and you are very organized in the way you define them in contract A. If you are not organized and you have way too many variables and you're always adding variables and you want to reuse them for different things, and there is like a lot of developers working on it, this becomes a mess. Because you have to now, any mistake that you do results in you overriding values, which is not good. So if you used a variable name called score and you accidentally you thought, oh, that's never used, and you did use it again, it will override the previous value. So these are some of the concerns that are out there, but again, with anything, as long as you know the goods and the bads, you can use it with caution. Cool. So, moving on. Okay, a bit about the EVM.
So sorry, just one last
Yeah.
thing, the previous slide.
Yeah.
So when I move from contract A to contract B2.
Yeah.
I would need to know the contents of contract A and all the variables in contract A and bring that into V2 to be able to access
Exactly.
the data.
So it has to be at least a minimum of contract A.
Plus something.
Exactly.
Okay.
Plus, or you can change
Change.
the function
Right.
which resides inside.
But if you want to access that whole data, it has to have the same exact variables.
Exactly. But there is a good thing, which is if you define your variables
Intelligent.
in a constant fashion, they will save memory because they will be injected into the bytecode. So constant variables, which are constant and never change, are not actually stored inside the EVM. They're stored within the bytecode, which gets compiled down. So yeah, exactly. Which means they are inside it. They're not actually being stored. They're not taking any slots. I'm going to go through that in a second. Okay, so in EVM we have three types of storage, or three that you care about. One is stacked. So everything EVM is a stack-based machine, so it pushes things onto the stack, it reads things from the stack, and you can do certain operations with the stack if you are doing things in assembly. The things we actually care about are memory and storage. So memory is any local variables you define within a function. They are only available when the function is executing. As soon as the function stops executing, they are lost forever. So that's the temporary memory you have while your function is being executed. And that's the local variables. Anything you define at the top of your contract, which don't live inside a function, that is storage. Storage is very expensive. If you want to store more things, you will be charged more things. And there's always there's a maximum, so that's where I think gas limit starts interfering. You can only iterate through stuff with a maximum gas limit. So you can keep adding stuff to an array, for example, but if it reaches a point where iterating from 0 to that point takes more gas than the gas limit of the blockchain, it will not work. So now the things that we actually care about is that storage is persistent, which basically means when you're defining an ERC20 token, you want the balances to persist across multiple transfer calls or anything like that. So you want the balances to be always updated and you want them to never go away. If you define a mapping, I don't even know if it's possible, but if you define anything within a function, it will not persist, which means the balances will get erased. So once you define storage, you can reuse it over and over again because the slots are given. When you destroy some of the data structures or your contract, you get a gas refund. The reason for the gas refund is to incentivize you to clean up. So if you have a lot of data that's now useless to you, you can destroy the contract or erase those arrays and you will get a gas refund. There was, I think, a gas token based on this, which was basically, the idea was someone buys gas when it's cheap and then destroys the contracts when it's actually expensive, and then you earn money that way. It's pretty clever. So that you can do. Okay, so we've talked about simple things. Is it clear so far? Is the page fine? Okay, so now I'm going to go back, and before I just said this contract will just call the storage contract for the things it wants. Now we've solved one problem, which is the data. We now have a data in one place and we can do as many upgrades as we want and the data will remain. But we originally started with two problems. What was the other one? Address. So the user still has to know the new addresses, and that is a problem. That the user always has to know, okay, what's the new one now, what's the new one now, what's the new one now? And maybe the user doesn't have to care. So can we do something where we can get, away with this? So now the pattern I'm going to go through is complementary to this. It doesn't use this at all. So forget all of this now.
Does this pattern we're looking at here
No.
have a name?
This, it does, but they have so many of them.
Okay, that's fine.
That's the-
I'm just going to call it separation of facilities then.
Yeah, I'll look up some names for you. I've forgotten names now because there's too many.
Create another one. Yeah.
Okay, so delegate call.
That's the name.
Now I'm talking to you about an opcode now. No, this is not a pattern. This is an opcode in EVM. So before I've talked to you about a normal call where the contract A calls the storage contract, and a normal call is very simple. It basically says at some point in time, it leaves the contract, goes to another one, gets something, and comes back. Make sense?
Yeah.
With a value, and then continues the execution.
This is like a promise.
Yes, well, that one is a promise. This one is just. So a delegate call is works very similar to normal call, except it passes the reference of its storage to the contract it's delegating the call to.
So this is basically passing still the function code, but just passing the storage by reference.
Yes, if you're coming from C++, that would be simple. Yes, but there's things that are slightly different. So the message sender and the message value is passed along with the delegate call. So if you have a chain of contracts where you have contract A, probably should have that's the right way. If you had contract A and B, and contract A was delegating to contract B, then B would not see contract A. It would only see who called contract A. So to B, if I am B, I don't know that you exist. I just know him. I would never even see that you called me. And there is no credible way of knowing whether I was called by a contract or I was called by a normal account. So in Ethereum, we have two kind of accounts. One are contract accounts, which don't have private keys. And the other one are normal public private key accounts, which hold value. I mean, any of them can hold value.
Doesn't this break that external party limitation that, any kind of contract chain needs to be started by an external transaction?
Yes, it does.
If this would break that, right? Because
So this would
know
not break that. So the thing is that you can never know who's calling you. So it does break that, yes, in a way. But essentially what it means is, in reality, you cannot have a transaction that starts purely from a smart contract.
Yes.
It always has to be triggered by someone else. So it has to be triggered
Okay,
by
so
an external account.
So even though it's actually, you don't know whether it's coming from somewhere, but you can tell that it is coming from an external.
You can't. So from a contract perspective, you can't. From an outsider perspective, yes. So if I'm a contract B,
Right.
I don't know with the call that arrived to me, is that from an externally owned contract? Sorry, is that from externally owned account or a contract? I don't know. And there is no way of credibly knowing that. I tried to solve this myself, but then I break it. There's one way of doing stuff, but it still breaks under delegate call. So delegate call breaks that assumption, which people had and then lost money because they didn't realize that. So what is delegate call actually useful for? When do you actually want to just pass your storage reference? Well, it was built for libraries. So you want to have, for example, a math library that does some complicated math, but you want to say, when you've done something, can you store it in my location? Can you store it under me, rather than storing it in your, because I really don't want you to store my results in something else. So originally it was implemented for that, but it also it also presented a solution for doing upgradability. And how does that work?
It's a delegate call, so we mentioned passing by reference if we're looking for analogies.
Yeah.
Does it relate to function pointers or is it more passing by reference only?
It's essentially passing by reference only, like you just say, you know, here's my storage, do whatever you want. But, so it calls it with its own storage, message sender, and then message value is passed along. So the contract that receives it does not know who actually called in reality. And all of the storage is held in the contract as a proxy.
So essentially, this is kind of inverting the previous pattern.
Yes.
Where the storage is in the. front.
Exactly.
Okay.
So now you've reversed the ways where you're saying, before you were saying the logic was being called, which then called storage. And now you're saying, I'm going to call storage, which is then going to pass along its own storage reference to a logic contract,
Right.
which can do things to it. So yes, that is right. Cool. Does that make some sense? Okay. Cool. So, a lot of you would not know this, but this is, so there's this thing, what we've talked about, this pattern is called proxy. And the proxy essentially means the proxy holds all the storage in itself and it passes by reference to a logic contract, which then does some logic and then it gets sent back. Now, there's two types of delegate calls in Solidity. One is a high level call. The high level call only will tell you one thing. The call was a success or failure. It will not tell you the things that were returned from that delegate call.
Oh, okay.
So it will not tell you the exact things.
So if you're doing like a math function, it won't give you the result.
Exactly. So it won't actually tell you that thing. It will basically just say, oh, it succeeded. But you won't be able to know what succeeded. To know that, we have to use the delegate call that comes from EVM, an opcode. And this is a piece of code that's being used everywhere. There's a tiny bit of variations that exist today, but essentially all of them do the same thing. And I'm going to walk you through line by line what it means. So, first of all, define an assembly block. So now you're saying to Solidity, I am going to write some inline assembly. I know what I'm doing, so there's no more type checking anymore. Just doesn't care. Now you're in a Wild West, so you can do anything. You're defining a variable called pointer, well, PTR, and you're saying, can you load 0x40 into this pointer? And what does 0x40 mean? 0x40 is a way of saying, asking the EVM to give you an empty slot. So a 32 byte slot, one slot, a starting position where you can start writing from. So now you're in.
Why 40? Why not 39?
That's just, they just defined it. It's just specification, yeah. Yeah. If you want to write something, you have to say 0x40.
Okay.
There's like no, it could be whatever. Right. So you now have a pointer where you can start writing from, and in the EVM, when you start writing, you have to know where to end. It can't just keep on going forever. So you have to know what's your limit on doing stuff. And now you're saying, call data copy is another opcode. What it does is that when someone calls the proxy, so this is inside the proxy contract, and I pass something along. So I pass, call the function A, something like that. All we're doing here is that we're saying, can you copy all the data that I've given as an external or contract inside this pointer, starting from position 0 and going until the call data size. So you're going to go as far as the call data size and copy it into this pointer.
It's called data size.
That's again coming from EVM.
Yes, an internal EVM
Exactly.
variable.
So all of these are opcodes, which you can look up in the EVM documentation.
Including call data size.
Yeah.
Yeah.
So I'll tell you, there's only one variable which is not coming from EVM, and this is this one. We'll get to that in a second. So now you have all the data inside a pointer, which now you can give to delegate call. So now you can tell delegate call what to do based on something. Delegate call has to know one thing for sure, which is what does delegate call has to know at minimum?
gas limit. The gas limit.
Sorry?
We have to know the
New
gas
address.
Yeah. Yeah, so the address on where to delegate the call. Where am I calling? What should I do? So that's this thing. This is defined up there, which you can't, like, I won't have no copy. But this is an address that we are saying ourselves what to do.
So that would be the address to whom you're going to.
Exactly. And we're going to see that full implementation in a second. So you're giving that, and then you're saying, can you please delegate call with gas, that's the remaining gas that's left in the call, to this address using this pointer. And every time you give a pointer, you have to say when to stop reading, which is you're saying call data size, exactly like that. And then there's some optional things that we don't care about right now. If you did, you could use them. But essentially all that will do is it will go to that contract with the function that you've asked it to call through the pointer, and then get the result back. And now you have the result. And that's all, we did all this effort to get the result. Because otherwise we could have used the normal delegate call, which all it takes is tell me where to do it. And it will tell you, it was a success or a failure. So now we have this. We also need, so again, return data size, call data size, return data size, they're all coming from EVM. Every time you make a call, or delegate call, some of these variables are auto-populated. So they are inside the EVM, and you know the size that was returned. You know that some data was returned, and now
So what is the size? Is it the data?
it's essentially
The result
the,
that is returned, right?
sorry?
Return data size would be the result that is returned.
The size of the result.
Size.
So the size is in essentially bytes on like how many, it's essentially the offset of when to stop reading. So you have these like 32 byte slots, and you need to know how many slots, or like basically it will calculate the slots itself if you just say like 42 bytes, 64 bytes or something, and it will say, okay, I'm going to read until 64 bytes.
And the reason result is in return data size is because it's a stack-based machine, so the last thing on it was result. So when you call return data size, it goes to the top of the stack and goes, results there, what's its data size? Put that in size.
Exactly. So what are we doing here? Well, all we're saying now is we've used this pointer with what it was before, and now we want to use this. We want to reuse the pointer. So we're saving gas. If you ask for a new pointer now, you'll have to pay more. But there's no need of getting a new pointer because we already have one, and it was only needed. So this pointer was only useful until this call was done. When the call is done and the result, we have the result, we can just override it with the data that is got back. Again, the same thing, 0 to size. Now it's just doing a simple thing. All it's saying is if there was no result that was returned, then revert. So in transactions, you can revert a transaction at any time, which essentially does everything that it did. So it goes back, and there is essentially no consequence.
Sure, cost.
Yeah. So the cost is gone. Once you paid it for the transaction, that's done. Otherwise, it wouldn't even get hacked, which is like that. So all it does is that it says if there is no result, then
Go back to where it was.
exactly just revert the transaction. If there was, then just return where we copied the result. So return the result essentially. This code you don't have to modify, but it's good to understand. So this is something that you will see me like just copy and paste, and it does work, but it's still good to play around with. because there's often things that you have to do yourself, which requires modification in this spot. And it's actually rather simple once you get the hang of it. Okay. Cool. So this is how it actually looks like. Ignore these two for now, and I'm gonna tell you why in a second. But all that's going on is someone's calling the proxy, it's delegating the call to contract A now, and it does whatever the logic is, stores everything here, and then this returns the result. So we've seen already the code that resides inside the proxy. Does that make sense? So there's a problem when you access raw storage. When you access raw storage, you are bound to make mistakes. Now that you've gone down to the assembly route, Solidity is not giving you any guarantees of storage collision or storage corruption. Now you have the literal raw EVM, which means anything you do in any block, in any slot, it will corrupt the storage for everything. And I'll show you that in a second. Which basically means you have to, whatever you do in contract A has to respect the storage layout of the proxy. What does the proxy needs to store? At minimum.
It's contract.
Where the address on the delegation, right? So that's one thing that the proxy needs to store. If it does it correctly, it works. If it doesn't, it destroys the layout. Therefore, if you want to preserve storage layouts, one of the ways is inheritance. What you can do is you can say the proxy has to store one thing, and it always must be the first. And I'll talk to you why it should always be the first. So proxy is a proxy storage. Anything that's there, it's just there for essentially documentation purposes. It's not serving any value. So all we're doing is that to preserve an interface, we're using this as an interface. All we're saying is the first thing that should ever be declared is the implementation address. Then you can do whatever you want. So this is again not necessary. You can just implement. You can just do it here. But the reason I have it here is the next time you do an upgrade, you have to respect now first this, then this.
Is the pink bits the thing we looked at first? Or not?
Before.
Yeah.
Yeah.
Okay.
So now we've essentially, as you said, reversed the things around. The storage is all here. This is logic. And because you've put storage first, you need to respect certain things. I'm going to go into that now to make it clearer.
Hang on, could you come back to the previous one for a second?
Yeah.
So you are in contract A is now inheriting from both proxy storage and A storage.
Yes.
So, so when you do contract AB2, that would also have to inherit from proxy storage and A storage.
Exactly.
Okay.
So it can modify, like it can add more things there in the A storage, but it should always respect it. So the reason I'm doing inheritance is because when you inherit from a contract, any content, any storage that's in that contract gets put into your contract firsthand. The order of inheritance matters. If you inherit them the other way around, you will screw up the storage. Because what it will do, what the compiler will do is it will say, oh, you want this first? Fine. I'll put that first, and I'll put that second, and let me show you what the difference
I'm
is.
sorry, why do I have a storage now?
So that's only there when you do the next one. So yeah, you will have to respect the previous storage every time you do upgrades. I'll show you in a second.
It's like turtles all the way down, right? You need previous storage structure.
Okay.
Address.
So,
Because you're delegating.
okay, let's do some. So, is that good enough? Should I zoom in more?
No, it's okay.
Is that good? Everyone in the back can see? Cool. So this is the proxy contract. It's very simple. It has one thing called implementation, right? It has a constructor which initializes the implementation. It has a function called setAddress which just sets implementation. And it has something called a fallback function. Do you guys all know about fallback functions?
It's like the default function call if there is any problem.
Yeah, so it's a default function if you call a function that doesn't exist, or if you just call it as a normal thing. This is a function that's called, and you can see the code from before. It's actually there. The only thing I've added is that implementation. So that implementation is coming from here, which is then stored up there.
When you say call it normally, what do you mean? Call contract normally?
So if you call a contract like as if it was an external account, so if you just call the address with nothing, with no specifying function, it will call this function. So what does that mean? It means if you go to your wallet and send this contract some money, it will call this function. So if you just look at like the address of this and say, oh, I'm sending it to this like 732B, it will call this function. And if this function is not payable, it will reject it. It will not accept your money. If this is payable in that case, it will accept your money and the money will reside here.
So you can have only one external function ever for a solution.
One fallback function ever, yes. Because you cannot, how do you decide between two fallback functions? Okay, so this is the function that will be called. Then I have two contracts, score and score version 2. Do you notice anything odd in score?
It's taking the address.
What's odd in score? Just score, you don't have to look at the score version 2. You can just look at score.
The address, the implementation address that was used.
Yeah, so should that be there? Should that not be there?
Isn't that the way to inherit from it?
Okay. Well, you can inherit in many ways, but yeah, that's one way to respect this right here. Okay, I'm going to show you what happens when you don't have it, and I'm going to show you what happens when you do have it. So make note of this because this is going to be important. Now we're going to see how to use the proxy. So proxy works in a way that's slightly unintuitive, but it basically means it pretends to be another contract to do the delegate calls properly. And we're going to use Remix, we're going to hack Remix for us. So, first of all, you've looked at the score contract, except this line 37. Everything else is clear, right? If we ignore line 37 for now. Okay. So we're going to deploy score. You can see it has a set score and a get score. And by default, it's 0. Expected, right? The idea of using the proxy is to say, you're never going to use this thing directly. This is only an interface. It's something that provides logic which will get executed. Not by score itself, but from a delegate call. Which basically means we need to take the address of score. So I'm copying the address of the score. I'm going to the proxy, copying the address of the score, and deploying proxy. And you can look at the address of implementation where it's delegating the call to here. So 11F5. Oh, 01F5, yeah, 01F5. Okay, so now we've linked the proxy to say call score.
Now, where is
But-
the proxy code?
The proxy code is up there. Okay.
There, okay.
So, we have the proxy. The proxy is actually going to delegate the call to the score, but we actually have to we have to pretend when we call proxy that we're actually talking to score, because we want to call the functions that are inside score, but through proxy.
Alright.
Does that make sense? So you can ignore the proxy code entirely, and you can see we want to call set score and get score. But when we go into proxy, it's just not there. So how do we do it? Well, we can hijack Remix to do this. You copy the address of the proxy and you tell it that, so there is this @address thing. Whatever you select here, it will, as Remix will assume that at this address, this interface resides. It will not double check. It will just believe you. And we want it to believe us because we're nice people. So we can say there is a score which lives at this address. We know that this address is of the proxy. Oh, I copied the wrong address. Sorry, that was good. So CFA, then we know that there is a proxy which lives, and we're lying to Remix that there is a score. Make sense? Okay. And the reason we need to lie is to get the functions within score. Otherwise, we will not get the functions. So we have a score here now. You can see that these two are identical. The address is the same. So we're just pretending to Remix that there's a different address which resides here. Well, there's a different contract which resides here, but we know as a matter of fact that it doesn't. And now we can set score. So we can set, for example, 12 and get 12 back. But if you ever go back to the score contract and ask it to get score, it will still be 0. Does that make sense?
Well, why is it 0? Because it goes
So,
from the proxy.
You had, It wouldn't, because remember the storage is in proxy, not in score. You're talking to two different things. Score is only used for the logic. Although it has storage, it never gets used.
So why, okay,
Can it get used? Could you do it wrongly and use the storage in store?
You can, but that would be a disaster.
Breaking the design pattern.
So you have to manually copy and paste the address in order to make it work.
right,
Well, it's just different, right? So when you do it in your actual code, if you're writing, like, for example, Node.js, it asks you for two things. Everyone will ask you for two things. One is an address. Remember that looking at an address, no one can tell what functions are exposed because we don't know. It's bytecode, which we can't actually read properly. So what we need is we need the ABI, so application binary interface, which defines the methods within a contract. So it defines the functions that reside within a contract. And based on that, it's always a guessing game, regardless of what you're using. Even Remix is just doing this guessing game. The reason it can do it this way, which is nicer, is because it knows the source code. In a lot of other cases, when you compile your code, the things that you need is the address, if it's deployed, and the API. And based on those two things, you make calls. If you have a wrong API, things will fail.
So essentially, you need a client application, and we're using Remix to be that
Exactly.
client.
You can do
so
it.
you can be writing it in Node.js, JavaScript, or whatever
Exactly.
the hell you like. And our client, we've got an interface on it, which is the Remix editor.
Exactly.
And it's our client, yeah.
Exactly. So you can do it anyway, but to have the proxy pattern work properly, it has to do that. So it has to say, use the ABI of the logical contract, in this case score, while using the address of the proxy. So proxy is deployed, that has an address, score has an address. You use the address of the proxy while using the ABI of the logical contract. Make sense?
Why can't I create a proxy that actually asks for that address?
You can. I'm not saying you can't. You can, but then, oh, that would be
Like
tricky.
like a
That would
regular
be-
function that has like, okay, pass me the address and the delegate address.
Yes, but how does it work? Remember that like proxy has to know which function to call inside the score. It doesn't know that itself.
But suppose you don't want to expose that, and you basically want to say, okay, so let's take this score implementation, right?
Yeah.
You created get score and set score. You know, it's going to be a this is a what do you call it, a parameter pattern. So so you and you want to use this function internally. Maybe you're going to tell the cricket score to somebody in the external system. So you just basically say, okay, I create a function saying get cricket scores, and you pass in the delegate address. You hard put delegate address in your proxy and say, okay, this is the.
Yeah, you can do that. Yeah. So that's a pattern which is used when you know that the whole reason we're not hard coding is because this score has to be upgraded at one point in time. If you hard code, it cannot be upgraded.
Right.
It's done
so,
forever.
Understood. That's fine. I can basically say, okay, fine. When you call get cricket score, use this address right now.
Yes.
Use this delegate call address, and it basically knows the functions internally. The functions won't change, right? That's an interface.
Yeah. So the proxy doesn't change. Yeah.
Yeah. So the only thing that's varying over there is the address, the
Yes.
delegate call address.
Yes.
And I can make that a part of my, I don't know, my wallet functionality or my
So you can
functionality.
you can do all of that. The problem that you would have to actually fix, which is a hard problem, is remember that you will be changing a pattern, right? You're modifying it to work in different ways. For example, the fallback function does not accept parameters.
Yeah, in my implementation, I'm just wondering why do I even need to use a fallback function? Can't I use a function? The fallback function is there. That's great.
Yeah.
But if it's a more complicated contract that wants to do more things,
you can always do more things. That's perfectly fine.
So you can't put everything into the fallback function. It would be like feature 1, feature 2, feature 3. Each one would be.
So the fallback function is doing something generic. That's why we have the fallback function.
Yes.
The proxy is doing something generic.
Right.
And the reason we're doing things this way is because we want things to work in a very particular way.
Okay, I understood. So what you're saying basically is that for every feature, so if I consider the contract score to be a feature, right? So if I'm writing a project that has 3 features, I would write 3 proxies for each
No,
feature.
why?
Because I wouldn't know.
You just have one.
Oh, you have one proxy with
You have one proxy and you can expand the logical. That's why we're saying proxies are storage. It doesn't care. So we've now changed the storage to say instead of having those mappings and having to do all the hashes and all this, we're just going a little bit more down with 5-6 lines more complexity and saying we're making it generic. It will work for every contract out there regardless of anything.
Right.
Now coming back to this thing, so now let's just go through an upgrade. So you can see that you've used score and that actually works, right? Using the proxy.
So now that's where the storage is in proxy,
Exactly.
not in the contract.
No, in the score
So-
contract. Yeah.
Okay.
Before we do the upgrade,
Yeah.
would you be able to go back to this last slide you showed us with the pink and green?
Yeah.
And then I can ask the question.
Can I just do that and then
Yeah.
I'll go back?
Sorry, yeah, sure.
Yeah, no, it's fine because I have to show something else and then we're gonna go back.
Maybe it'll make it clearer as well.
Yeah. So, okay, so I'm gonna do the upgrade and then I'm gonna show you why we have this thing and what happens when we remove it. So we have the contracts already. You can see these two are just proxy, just wearing different clothes. Now, to do the upgrade, I'm just going to show you score version 2. And score version 2, the only difference is that set score sets the score +1 to whatever you say. So we've changed the logic in a very complicated way, and I've stolen it from Lawrence. So Lawrence uses score, so it was a nice thing to steal. So we can just deploy score version 2. It has an address. We can copy it, go to the proxy, say now you're delegating to this address. So, and we can check that the address is right. So it's 137.137. Perfect. The benefit of using the proxy is you don't have to go and do anything else now. As long as you've not added more functions, we can go back to the same score contract, now see what happens. So same score contract that we've used before, and I'm going to say set score. And when I get the get score back, it's 33. I didn't actually need to do anything. There was no need for me to go and do the same thing that I did before, where I pretended that score was proxy, or proxy was score.
How did the 12 get transferred to the newly deployed upgraded contract?
Remember that they had storage, the new one. The old one didn't have storage. The only storage always resided in this CFA address, and this CFA is a proxy.
Sorry, yeah, we've updated the contract, not the proxy.
Exactly. So we've updated where it points to, but we've not upgraded the actual proxy itself.
And how come that storage is not in the data bit? How come that's in the proxy? That's what I'm saying.
So this is in this pattern, the proxy is the storage. You'll get used to it in a second.
Sure.
Okay, so I'm gonna remove everything. So
So
like
the
it
store
here.
that holds the storage is actually proxy, but it's named storage. Because we like.
Yeah.
Right.
Yeah.
If you could you tell me, so how, you said you could set the address, the implementation address.
Yes.
Uh,
That's defined.
That's that constructor address, that's set address, okay.
So, okay. So now the question is, what is this guy doing there? Right? As I said, you need to respect, when you're writing your application code, in my case code, it has to respect the storage layout of proxy. Now, if you look at the actual storage layout of the proxy, it has only one variable. The names don't matter. The data type does. Names don't matter. You can see it probably scores different things in different contracts. That's completely useless. The names are not stored in bytecode. They are only for us. After compile time, the names are gone. So
So it's type and presumably order. Which you don't
yes,
know about.
type and order. Yeah, exactly. Now I'm just going to show you what happens if you do the exact same thing, but score does not have this. So I'm going to just comment this out. Does that make sense? So now the score is exactly what you would have thought in the first place, right? So same thing. So we're going to deploy the score. We have a score which has no score right now. Remember never to use the storage of the score itself. You're always going to go through the proxy, otherwise anything you do will be lost. Okay, so now we're going to go to the proxy and we're going to say, can you please point to this address? And same thing as before, take the address of that, go to score, put this, and we have a score. Remember that these two are the same. So now I'm going to say set 12, and I'm going to get score back, and it's 0. It doesn't matter that I'm trying to set, it just keeps failing. If you look at the actual transactions, the transactions are succeeding. And when you get the thing back, it's 0, so it's not working. And now what happened here? Look. As far as we remember, we said it correctly and it was fine, right? Maybe something went wrong, so let's try again, right? So you can see this, it's EF, yeah, so it's now pointing to score, right? Is that fine?
Yeah.
Now I set the score, get it back, still 0. Can anyone tell me what's happening?
It's going in overwriting.
You've lost the address, I was going to say.
Exactly. So every time you call the function here, remember that these two are the same. You're overriding a storage slot, which was meant to store the address, but you're storing something else in there, and it's being encoded in the form of an address. So C is 12, but it's encoded in the form of an address. Okay, now we can get back to the slides.
So if it was the mainnet, it could potentially go to some random contract.
Yes, yes, it can. If you put a number that would
That
resolve.
is sufficiently big.
Yeah,
So is that not security?
It is.
Yeah, mainly.
it is. So this is what's happening. You've seen it live. When you define any global variables, it starts defining at a location called 0x0, then 0x01, 0x02, and so on in hexadecimal. And it keeps on going forever. Same thing here, 0x0. Remember that now you're using storage as the hardcore thing. You're telling it to store at 0x0 by literal means, because there's no more solidity anymore doing things for you. Solidity by default is just saying, oh, first variable, 0x0. Second variable, this. There are exceptions for mappings and arrays on how they're encoded, they're different, but in any other variable, it's always the same. Okay, so this is what's happening, where this is colliding, and every time you set one, the other gets unset. Every time you set the other gets unset. And the way we were fixing this problem was saying,
You are just padding.
exactly, we are just padding. We are just saying we're respecting the storage layout of the proxy. And we're doing this by just mimicking the layout, the storage of the proxy.
That's a very brutal way of doing it. I mean, one mistake and you're screwed.
Exactly. That is the whole point.
This is C++.
This is C++.
Polymorphism by hand.
Exactly.
Welcome. Welcome.
No
this is why I stopped doing
no
C++.
zero class, zero base
Yeah.
class optimization whatsoever.
And
So there's no optimizations, you're doing everything by hand. Now, we've gone to this, so we've gone from the morning, we've gone from one problem to another, but we fixed one problem.
which is the address.
Address. The proxy's address always remains the same regardless of the number of updates, right? Now, we've solved both of the problems, the data remains and the address remains, right? But we have one more problem that we would like to solve. This is annoying. We cannot, or it's not ideal to always remember to put address on top of every contract we ever make. So, this is something that came along and said, how do we solve this now? We want to, there's one thing clear, we have to have the implementation address. But no one is saying that we have to have it at 0x0. You have the infinity of choices, well not infinity, but anything that's known. Any known value can be done there. So, this is a pattern called unstructured storage, which is essentially using proxy. And all that means is we're going to not store at 0x0, but a random position in memory. How do we get random things? How do we get random 32 bytes key identifiers? Exactly. So if you hash any random string, you will get a random key where you can store something. where you can store the address. Does that make sense?
Yeah.
Hang on, so what you're saying is, we take a random string, we
Yeah.
hash it, and we take that hash as the address for the address.
No.
The
For the
memory
proxy
address, the
control.
memory point for.
Yeah, exactly.
Okay, but what happens if in that memory point there's some code?
There wouldn't be.
Why not?
Because every contract has its own storage and all the slots are for you. Because they're essentially indexed under your contract address. The way the storage works in AVM is that you have everything, no one else can override it, only you can, and you can store anything you want. And the chances of anything happening is so low that it doesn't even matter. There is essentially almost, you can run out of, like, in our lifetimes, you can
Something
never.
else is going to go wrong first, like the machines.
Exactly. So there's essentially a lot more things to worry about. But this is called unstructured storage, and we'll try to implement this today as well. Let's look.
You know when you had the example with the C at the end instead of 12, where it messed up?
Yes.
You could only mess up your own EVM.
Yeah, you
address
can't mess up
storage.
someone
You could-
else's
Yeah, I
contract
was,
unless.
when you said it at first, I thought you were sort of
No.
destroying the whole of the Ethereum concept. I was like,
No,
Yeah,
you
but
can only
So-
destroy your own.
point
but you,
was-
yeah.
The point was like if the address matches somewhere.
Oh, yeah.
What you would do, if I was a bad guy, I would basically find the address to my contract, find the integer that matches that,
Yeah,
find the integer that matches that, and pass that in as a score.
yeah.
So then that address gets updated to my contract now. So the next guy who comes and calls a proxy with that particular address
Actually goes to.
comes to my contract.
That's what I was.
Sorry?
Isn't that hitting somebody else's address space?
So yes, but you
Have
can't
like
modify it.
contract
Remember,
from-
you can't actually modify it. Like you can't modify someone else's address.
You're not corrupting my address space,
Yeah.
I'm basically sending you to my contract.
So it's
So
like
if-
masquerading.
Yeah. So basically, yeah, you can do some things like that, and then it depends on what
Well,
the
it's-
application is to actually make sense of it and so
Yeah.
on.
So in other words, to whoever was using my contract, you could use that
You can
method
hijack.
to,
You can hijack.
Yeah,
Yeah,
and,
to
and they
send-
think they're using
And then,
mine, but
yeah,
they're using yours.
and then I can do bad things
Yeah.
Yeah, to the user.
So
to the user.
this is an example. An example would be parody
Thanks.
hack, parody multi-sig wallet, which got the library got destructed.
Yeah, somebody went.
So that's exactly what happened, where he saw, an open function where there's no owner set. Fine, I'll set it myself. There is a self-destruct function. What does this do, I wonder? Press that, about 200 million items, something like that. It's still in Ethereum, which is now cannot be accessed.
Yes.
Because the library which does the math for adding and
But the
subtracting.
parity guys keep going and looking at the value.
If they take that out now, Ethereum is probably gonna go very low value. But okay, so how do we do the unstructured storage?
Yeah.
We talked about we want to use random location in memory. How do we do that? Well, you store. Welcome back to assembly. So the only way to decide where your things live is if you do it yourself. So there's two variables two opcodes that are important: store and sload. The first letter defines storage or memory. So in the previous one, you've seen mload, which is memory load, and storage load. So that's how the naming scheme works.
Right, and S-store is global storage.
Yes, exactly. So it again takes the two things, the key and the value. To get things back, you just need a load and the key. So very simple. Get the key somehow by hashing something, and you will get it back. So that's rather.
Wait, sorry, so what's the difference between mload and slow?
So mload is memory. It will go away. It's not persistent. If you load something into memory, it's only there until your function is running, and a fallback function is a function. So as long as that function is running, you know the contents. As it reaches the end, it gets destroyed. In sload, it's persistent. Sorry, the store is persistent, and you're loading from persistent storage, or you're loading. It depends on what you're loading into one thing or the other.
Also, it's like the memory and storage we had before the.
Yeah.
Yeah.
So you cannot do an mload here on this because there's nothing in memory to load from. You have to say I'm loading from storage, not from another space.
And what is reg key?
That's just
It's
a
okay.
variable.
Okay.
A variable that's not inside the thing.
Right.
But yeah. Okay.
And why use this type of storage to the other type?
So the benefits is that in the other ones that we went, we were stuck at a point where the users had to know addresses every time we did upgrades. And with proxy, they don't. So there's reasonable justifications for using one and the other, and they both are being used, and variations of them are being used. People generally use proxy as a means to sound cool, because it's like, oh, look, it's magic, it's doing this delegate
My
call.
least favourite word in IT, have to just do this.
I know, proxy is like,
It's so confusing.
yeah, it's something that came up, it got in, and there's very few people who actually understand it, but there's a lot who actually use it.
So this
So,
was created by the people who actually create contracts. It's not something that like.
no, it's not part of the
should
actual
do-
EVM
yeah.
or something, no. It was basically, so 3 years ago in 2016, when delegate call was added to the EVM, to support libraries, to do these things. One of our mentors who used to teach, Nick Johnson, he realized that there was a way to do upgrades by using delegate call, and he wrote the first ever proxy contract, which just because it was really cool. He didn't ask anyone to use it or anything, and then it got really famous, and a lot of other companies and projects took that idea and used it for more things. So,
I hope they got audited properly.
sorry? Yeah. I mean, you can audit it. They are auditors themselves. So Zeppelin, Open Zeppelin is the one that's mainly using this, and they have variations. They have transparent proxy, this, that, and the reason I don't like names is because of that. That every time you talk to someone, there's always a lot of names thrown at you, and when you actually go and say, what does that mean? They solve a very tiny problem for what they consider to be revolutionary. So it's always interesting to know about this.
Generally, if you were to try to say what is a proxy, whether it's a proxy networking server or it's a proxy here, it's kind of like a copy that's not a complete copy, right? Or a copy that references something.
It's basically something that serves, but it's not really there. So a proxy
serves, but it's not really there.
Yeah, so it's basically you don't want it to show anywhere. It just, the whole point is that it passes around. In proxies, you always pass around to something else.
Man in the middle.
Exactly. So it's always just the man in the middle.
Thanks.
Okay, I took way longer than I thought. We're going to finish in the last maximum 10 minutes. I promise you that. Okay, so far it's been pretty trusted. We assume that someone does the upgrade. So I didn't actually talk to you about I was doing the upgrade, but anyone could have done it, which is not a secure piece of code. So as I told you, ownable pattern that's used to prevent that from happening, but that means there's trust. You trust the company, you trust whoever's doing it so far. The solutions are generally governance, always voting. I don't really care about voting at all, or even think that works. The main thing is that...
Isn't Aragon all about voting?
Yes. I didn't say I like them at all, I just said their contracts are breaking. So what you can do is, we can get something which works partially. So it works in a best case scenario, and it serves also in worst case scenario. So now we want to essentially say cater for upgrades for people who actually care and want to take responsibility can do it themselves, for people who actually don't want to do it can let the company do it. So a partially trusted system. We want to like ideally make it trustless, and also the same thing is like right now. I mean, this is I've been saying that for a year now. There isn't many contracts out there which employ any sort of versioning. You always have to use the latest version, and regardless of how many bugs there are, regardless of what it is, you always have to use the latest
But
one.
honestly, it's kind of not their fault too, right? Sometimes Ethereum moves fast and they
I know,
change
but
it
like
all.
you can write your contracts in a way where you can at least version on your part, and hopefully the underlying layer will stabilize into something sometime, and then we can use it.
But the downside is that it keeps on breaking, right? If your contract is not structured and if all the changes happen.
Yeah, I mean it's
So
not.
you're actually not version controlling it at all. Version control is like building on something,
Yeah,
but in this instance, it's actually recreating it.
yeah.
So it's not.
Okay, so one of the ways we're going to look at to make things trustless is, so this is something I came up with about a year ago, or just a little over a year ago, which essentially means, again, there's no, there's nothing revolutionary, just basic things. All we want to do is that we want to say, we want the user to have control over where the delegation happens. And I think this is what you were referring to before. And to do that, we cannot do it through parameters, we have to do it through some sort of registry. What does the registry mean? Well, it means you can specify preferences. So you can say, you can store the versions that are currently live in the registry, or ever have been live, ever have been upgraded. And you can say the user can decide to do the upgrade themselves.
They can choose which version they want to use.
Exactly, through the registry. So the user can go to a registry and say, whenever the company upgrades, do not upgrade me. And the registry will, when the proxy asks the registry which version, it will tell you the previous one for a specific user. Now, the best case scenario is everyone trusts the company, no one goes to the registry, and the registry always, like the proxy always just does A or A version 2, whichever one. Worst case scenario is no one trusts the company, they all go to the registry and say, I don't trust the company, please always just give me to A. And in general case, except one scenario, it always works. So there's a worst case scenario, there's a scenario where the company can say, I want to steal everyone's money, and they can do essentially something with the proxy to make that. But it's complicated, and they will have to go through quite a few things. But again, that would basically destroy everything.
So this isn't foolproof.
No. Let's see if you can find this bug today. There's not many things foolproof. It's essentially all of those theories. It only takes X amount of time before something is broken. So we know it works today, but we don't know whether it will work tomorrow or not. So yeah, I've told you there is a vulnerability, and it would be interesting to see if we can find it. The code is also available for you. But this is one of the ways you can do things. Does that make sense, the registry?
So who creates registry?
Oh, that's interesting. The registry is actually created by the proxy on its deployment, and it's not owned by anyone. So the registry in itself is pretty trustless. No one owns it. Anyone can only do things that they can do to themselves. They cannot change the behavior for anyone else.
What is the registry? Is it a contract?
Yeah, it's just a contract which has mappings. Just fancy. But it stores things, so. And every pattern that you've seen, the code is available, and I will walk you through in the afternoon sessions. So it's not theoretical, it's actually been implemented. But yeah. Okay, so something I'm going to go pretty quickly is you can use ENS names to point to different versions of the code. If you want to, that's just a nice way to say version 1 dot, mycompany.eth or something like that.
Right.
You can do. That requires you to have
An ENS name.
yeah, but also ENS has to do things. If you own your ENS, then it's not trustless. If you don't, then you can make it trustless, but it's up to you. And if it's not trustless, then you can hijack your supplements and so on. You can basically manipulate them to lie to customers and so on. So you have to be careful. This is something that a lot of people do, which is like if you give every user their own proxy contract. So right now, so far we've talked about one proxy contract that everyone's using. Now, a lot of companies are doing this because this is fully trustless. So you basically say, every one of you have your own proxy contracts, you know your addresses, and basically you have to do upgrades yourself. Anytime there's an upgrade, you are the owner of your own proxy and you can do the upgrade, no one else can. Does that make sense? Okay.
So basically, they publish the new version publicly, and then you basically.
Exactly. They basically say, this is where you should point to.
Check it out, and then if you like it, go into that.
Exactly. But they can't force you to if you don't want to. Of course, they can take away the other contract that it points to, but that's different.
How can they take it away?
Because that can be owned by them. That's not owned by you.
Yeah, that's true.
So
But you could theoretically take that, create a copy. And then
yeah, but it won't have your data and no one will trust you.
No, but then it's, okay, that's true.
It's like they do double things. It's the reverse that they verify. Okay, you can also do user contract with permissions. The idea here is that you start by saying, I am going to make it essentially an ecosystem or adapt essentially where you have a contract of your own, but I am an application which is allowed to do something on your behalf, and you decide what those things are. This is more philosophical, but like I've implemented it for one of the companies, and it works in ways when, so at the time I didn't like proxy at all, and because there was dynamic links, there's no way to actually say it will always work and so on. Whereas with this one, you basically say, I can upgrade my company thing, and you can authorize me to do that, to do some things for you. So you reverse the way things work. This is slightly complicated from intuition, but it works in a nice way. It's not famous or anything like that, but if you want to know more, I'll post a link of the article for this.
What does the second line mean then? So the first one I think makes sense now, right? Based on what we've been talking about.
Yeah. So this essentially takes everything you know and reverses it to say you have your contract and we can add. So the idea here was like, for example, GitHub as a company can have a contract called GitHub that they control. Then you have a contract that you control, which is maybe created by GitHub for you just as a benefit. And then you define the rights of specific things that GitHub can do to your profile. For example, they can't take your money, but they can add, stars on your behalf.
Yeah.
Something like that.
Money. Yeah.
Yeah. So they can't take away your money, but they can do other things on your behalf,
Stars on
and
your
that
behalf
works.
makes sense.
Yeah. So and that contract becomes your identity.
Is this similar to the concept of a smart contract wallet?
More or less, it's identity. Yeah. Yeah.
But do you have access to the stars, for example, or just GitHub have?
You have access to everything that's on your contract. Yeah.
And GitHub have to some bits of it.
GitHub can do things on your behalf that you allow them, but at any point in time, you have the ultimate control of taking away GitHub's rights. So essentially, it's like you have your own portal where you can go and say, I don't want GitHub anymore, and now they can't do anything.
So how would you code that? Because
It's already coded.
Sorry?
So
We'll see it later.
Yeah.
Great.
I'll forward the links, but if you want to know more about it, I can talk in breaks or afterwards, because it's
Yeah, I don't think you're gonna have lunch now.
Skip the lunch.
I'll let you guys speak and then eat lunch.
So the problem with all these methods is if it's become like widely used, it has to be common users must be able to use all of these things. I don't think a lot of people can use the proxies.
Exactly. I mean, the thing is that if people do it because they want to make users' life easier and still keep it permissionless, then there's a lot of solutions. But the problem is that everyone wants to make their own things, like to say, oh, we created this, we created this, we created this. And that's why we had like if you go into the identity space within like just Ethereum, there's like 8 or 10 groups saying, oh, we're identity. Like there were at the time there was like ERC 725 and C 735, which was identity related. They were not even thought of. They were not practical at all. Anyone who tried to implement them was basically saying, hey, this doesn't work. But when
Somebody
so-
owned it, I said I put it over there.
yeah, and anyone you go to in so many presentations, you would basically be like, oh yeah, that's ERC 725, and then actually I spoke to every single person and said, show me how it works, or like, does it actually work in reality, because it doesn't do this, and it's like, yeah, it doesn't. So I don't think it may converge, but it will converge out of necessity. That there's at least one company which makes something that gets so popular that others just have to use it. It's the same thing with like signing with Google, signing with Facebook, and other
So
things.
you don't have to rely on the company to upgrade.
Yeah,
Well, it's not that much different from what we have today, like.
yeah. Every system has its own ways.
Yeah, but I
to do
thought,
it.
we're
So
using
upgrade.
Ethereum because we want to go away from trusting companies.
There's a very big problem when you put very smart people into one room. Is that you end up with so many solutions and all of them are great, but they don't work with each other at all.
So consensus is the toughest part for
Yeah.
Ethereum people.
Yeah, it's a nightmare. Yeah, right now it's basically, even though it's been around for 3-4 years now, and still everyone is doing their own things because they raised money to do that. So remember that if they converge with someone else, they have a lot of people who bought tokens who will come their way and say, well, you promised me this. So that's one of the reasons why a lot of companies who want to go with something else, they just can't, because the way they raise funding was that way.
That can change, right? So
That can
that's-
change, and that's already
it's
changing.
not a-
Now smart contract, they're finding them too.
Yeah. So yeah, change the smart contract.
Okay, final things. There's also remote period things which already happened with ENS, that every time you do a migration or stuff like that, you cannot do it. You should not do it immediately. It always has to be always some period of time where you say, when someone enters your contract, you tell them, if there is something that you don't like about us, we'll give you 2 weeks, 6 months, 1 year before you have a chance. You have a chance to leave or upgrade to the new one. So these situations do come, and with ENS, this recently, oh no, that recently now, but it happened where you had to migrate your old domains to the new domains, and there's 1 year period that they said, if you don't do it within 1 year, you lose the domain. So either you upgrade or you decide not to do it, and after 1 year you lose it.
But until then, you'll have
You
the
still hold it.
grace period where it will still work and you
Exactly.
can go and implement it somewhere else.
Exactly.
But it's nothing to do with moving your coins out.
No. I mean, it depends on the application. If your application has it, then sure.
There are applications like that. If you write, for example, if you take Moloch down, right? Have you heard of Moloch down? Okay, so you should check it out. It's a pretty interesting concept. So what they basically say is it's a decentralized autonomous organization. It's kind of like a VC kind of thing where you can put money. So every time there's a new proposal, they vote on proposal, right? And if you do not agree to that, you at any point in time, if you do not agree, you can just get out.
Yeah.
And take your money with you.
And take it.
Yeah, yeah. Okay.
What's it called?
Moloch, so MOLOCH.
Yeah.
So
It has like
make it out, but
No, make it as a stable coin. This one's a investment vehicle. So if you basically you go to Moloch DAO and ask for money to do a new company or do a new library or something like that.
Yeah.
thanks.
Okay,
Just
so-
saying,
Finally, some final comments about Solidity and Ethereum that may be useful. Constructor code is not saved in bytecode. So constructor code is not something that gets on chain ever. It gets discarded before it reaches chain.
Constructor code being, can you show me?
I'll show you in a second.
Yeah.
I'll show the actual thing. And every transaction must have an ounce greater than the previous mined transaction. If you're sending batch transaction, it's very important to make sure that the ounces are greater. And remember that if the previous transaction did not get mined yet, your new transactions will have to wait until the previous one gets mined. Contracts can call other contracts, contracts can destroy themselves, and you cannot control incoming ether into the contract. Does that all
I
make
didn't
sense?
understand the last one.
Do you guys want me to go through it, or how many people want to go through it?
Yeah, yeah.
Yeah, one.
Okay, so if another contract self-destructs, then they can send the money to your contract that you cannot say, I don't want to accept. You cannot accept some payment from someone who just died. You cannot deny the payment from someone who just died, from a contract that just died.
Okay.
But why would somebody on dying send you money?
Well, just to mess with
Not
you.
somebody, I mean, a contract on.
Just to mess with you. So there were contracts which had a condition to say, once I reach exactly 10 ether, I will send the last person who sent me something, all of that. The condition was equals, exactly 10 ether. To mess with it, and it only accepted payments of, exactly 1 ether minimum, and in full payments. So it only ever accepted 1 ether each. But someone forced it by making a function and sending 0.000001, and now that condition, once it got 9 ether, can never, once it went above the 10 ether, it can never be done again because it's destroyed. You cannot do it. So there's a lot of these contracts which have these amounts hard coded. That's why you should always ever do greater than equals to, less than equals to, but never equals to.
Right.
So that's just something to know. The other things I've already talked to you about the grade 2 in the morning. Lastly, we need more trustless upgradable strategies. There's some that exist, but there's new ones that you can come up with. And that's what this is all about. So that's it for the presentation. So it took that long, but thank you.